Hi, today I'm going to talk about the reactance of capacitors and inductors. Reactance is an imaginary resistance within an AC circuit containing a capacitor or inductor, or maybe even both. The reactance of a circuit is highly dependent on the frequency of the AC source. When a final value is found for the reactance of a circuit, it will be expressed in ohms. Reactance in a circuit containing a capacitor can be calculated using this formula of Xc equals 1 over omega times the capacitance. Since omega is equal to 2 times pi times the frequency, this will allow for the calculation to be easier to apply. Generally, in these types of circuits, when the frequency is high, the reactance of the capacitor reaches a value close to 0, hence acting as a short circuit, and quite the opposite for a low frequency, acting as an open circuit. Here is an example of a capacitor in an AC circuit, the AC power supply being 10 volts and 70 Hz in frequency, and the capacitance of the capacitor being 15 microfarads. To find the reactance, we use the formula provided earlier, being Xc equals 1 over omega times the capacitance. Here we simply use a method of substitution, as we substitute the frequency f in as 70 Hz and the capacitance as 15 times 10 to the negative 6 farads. This gives a value of 151.576136 ohms, which rounds to 2 decimal places to 151.58 ohms. The reactance of a circuit containing an inductor is calculated using the formula XL equals omega times inductance. Like before, omega equals 2 times pi times the frequency, giving an easier formula to apply. Generally, with the frequency being quite high, the reactance goes close to infinity, acting as an open circuit, and quite the opposite for when the frequency is low, leading to a short circuit result. Here is an example of an inductor in an AC circuit, the AC power supply being 10 volts and 70 Hz in frequency, and the inductance being 15 millihenries. To find the reactance of this circuit, we use the formula provided in the previous slide of XL equals omega times the inductance. From here, a simple method of substitution is used, substituting in the frequency as 70 Hz and the inductance as 15 times 10 to the negative 3 henries. This giving a value of 6.597344573 ohms, after rounding to 2 decimal places being 6.60 ohms. Thank you for watching this video, and I hope it helped with any problems you may have encountered.